We're now entering section 8.2.1, which is introducing imaginary numbers. Up until this point, we would say when we are solving a quadratic and got negative under the square root, we would say no solution. Some of you may already know that that's not necessarily true now that we are going to be looking at imaginary numbers. So there was an Italian mathematician named Bombelli, and he's the one who discovered the imaginary numbers, and he was using a formula to solve a third-degree polynomial. And when he applied the formula to a particular equation, the number under the square root came out negative. And instead of giving up, he already figured it out that the equation had a solution. So he decided to see what would happen if the pretended that there was a number he could square to make a negative. And he was able to continue the calculation. And that's where he eventually decided to name these imaginary numbers. And this led to the acceptance of it. So the first thing is, if we're looking at x squared equals -1, we would now say that that negative part is actually imaginary. So the solution would be x equals plus or minus I. So we use I to represent the imaginary part. So therefore, that means I squared equals -1 if you were to work backwards. Just like we could say the square root of 25 is 5. So 5 squared equals 25. So that I squared equals -1 I highlighted because it will come up a lot within this chapter. And then just to kind of go what this means graphically, if a quadratic has two solutions, that means that it crosses the x-axis twice. If we have one real solution, it crosses the x-axis once. Now, if we were to get a negative number under the square root, it means it does not cross the x-axis, but that's where we have imaginary solutions. So you can see I drew a graph. So this is what we would see if we had complex or imaginary solutions. So we're going to go ahead and go through a few examples to practice using imaginary numbers. So if we have the square root of -4, we would now say that that is 2i. And then if we have 2i times 3i, so what we're going to do is multiply the real parts and then multiply the imaginary parts. So 2 times 3 is 6, and then we would also multiply I times I, which would be I squared, but we learned that I squared is -1, so you actually never want to leave I squared as is. You want to keep simplifying it. So we end up getting -6. On this next one, we have 2i, the quantity squared, times -5i. So we want to distribute that squared to both the 2 and the I. So this would really become 4i squared times -5i. So let's think about this. Well, we know 4 times I squared is really 4 times -1. And then times -5i. So we're really doing a -4 times -5, and then all of that times I. So it would be 20i. When we have the square root of -25, that would just be 5i, since it's just the principal root. But now that we're getting into x squared equals -81, we know we're actually going to have two solutions because we're now solving a quadratic. So we would square root both sides, and when we do that, we get x equals plus or minus. Now, because it's negative, that means it's going to be imaginary. So you really just take the square root of 81, which would be 9, and then you put the I for the imaginary part. Now this one, we would square root both sides. But in this case, if I were to solve just x squared equals 7, it would just be x equals plus or minus root 7. But in this case, we have the I, and it is preferable that you actually put the I in front as opposed to doing the square root of 7i, because that almost looks like it's underneath the square root, which would be wrong. So definitely put it in the front. So the other part of this section is just talking about complex numbers and complex solutions. So a complex number is the sum of a real and imaginary number. So it's in the form of a plus bi, and a represents the real part and bi represents the imaginary part. We could technically say any number is complex, because if we have the number 3, we could say the real part is 3, and then the imaginary part would be 0i. And vice versa, if we have an imaginary number as 5i, we could say the real part is 0 and the imaginary part is 5i. So when we get complex numbers, it's obviously going to be when we're solving quadratics. So here would be an example. So if I want to solve this equation, I would set this equal to 0. So we get 0 equals x plus 3 squared plus 4. The next step would be to subtract 4 from both sides. So we get negative 4 equals x plus 3 squared. Then we would square root both sides. So automatically I know I have to have plus or minus, and then I also know it's going to be imaginary. So this would be plus or minus 2i equals x plus 3. And the last step would be to subtract 3. And to keep it in that complex number form, or a plus bi, you put the real part first and then the imaginary part. And that's how you write complex numbers. So this just gives you an intro of how to work with imaginary numbers and what a complex number is. And in the next section, we're going to learn how to do operations with complex numbers.